Yeah, so Bruce, the floor is yours, or the screen actually.
All right. So can you hear me okay?
Yes, yes, yes.
Yeah. All right, let's get it started. So picture this scene. It's midnight and we're in Montreal. Our office is on the 9th floor of our building in the center of Montreal, but it's empty. But things are starting to go a little bit crazy. So the lights start flashing on and off, the air conditioner starts turning on and off, and computers are starting to operate without anybody there. Now, at the exact same time, I'm in Tokyo. It's hot, humid, but I'm cool because I'm standing in the middle of a conference room. Now, all around me, in KDDI's building, in the middle of Shinjuku, I have middle managers from KDDI that are trying to look at my computer screen. Now, huddled all around me, we're watching me remotely from the other side of the world control my office, controlling the lights, controlling the air conditioning, the equipment, and pretty much everything else in there. Now, it's pretty cool, right? Well, this was the year 2008, and I was CEO of a company called Hexago, and we were demonstrating our product that was a networking platform for home automation. At the time, we were selling it to service providers like KDDI, which provided home automation services to their customers. Now, I was demonstrating a connected product 8 years ago. 8 years ago. So what I'd like to do today is I'd like to discuss the difference between a connected product, a smart product, and an Internet of Things product, or what I like to call an Internet product. Second. So as I was introduced, I've got a little bit of experience in IoT. Right now, what I'm doing is I'm advising vendors on their marketing and IoT market, but mostly what I work with is enterprises that are developing IoT products and releasing them into the market. And as mentioned, if you go to my website, www.iotinc.com, I do podcasts, I do video interviews, I have webinars like these ones, and I have different special reports. Now, my background is in mathematics. I'm originally a mathematician and a programmer, but I worked in marketing, and then I've been the CEO of a number of different companies. And as mentioned as well, I am releasing my book on IoT early next year, and this is a lot of work. Now, if you want to get a hold of me, the best way to do that is to contact me at bruce@iotinc.com. So I'm going to go into the presentation now, and as said, we're going to go through it. I think probably just with the structure of how we're setting it up, that we'll probably answer questions later, but I'm going to go through the presentation and then talk about why you should not be developing a connected product, why you should not be developing a smart product, and why you should be developing an Internet of Things product. So let me go back to the presentation. We hear the term, and maybe it's a nomenclature thing, or maybe it's just my problem, but I don't like the term smart product. Smart products have been around for a long time. Connected products, as I demonstrated, we had a connected product. I was actually using an iPhone 1 at that time, and I was controlling it on my iPhone 1 and demonstrating connectivity that many years ago. Sometimes people call them smart connected products, and again, I don't think that really drives home the value of the Internet. So what I'd like to talk about today is an Internet product, or an Internet of Things product, and what we can do to bring the whole force and power of the Internet onto the product. First of all, what I'm going to do, though, is I'm going to go through the technology, but I'm going to look at it from a slightly different perspective. So most of the time, people talk about IoT tech. They talk about it like networking tech. You know, they look at the layers. We go all the way from the hardware to the app, and effectively, what you're doing is you're just viewing protocols. You're looking at see where the packet is going, but in particular, you're defining the product as a series of different protocols or standardization or layers that are taking you from, again, from the data from the sensor all the way to the application. I don't think this is very illustrative, and specifically when you're looking at it from a business perspective. Now, I know most of the people in the audience here are in startups, and they're trying to look at their product, developing their product, maybe it's an Internet of Things product, and what I want to recommend is not looking at your product, at least from a business perspective, not looking at your product from this point of view, but looking at it from a slightly different view. Now, when I work with my customers, we often will bring in design firms. Now, these are often coming from the mobile world, and they see an opportunity in IoT, and so they have the experience in the front end, which is generally the mobile app. They have experience in the back end, and they have the enabling technology in between. Now, I think this is a better perspective, but again, it's not really going through from a business point of view. I like to look at it a little bit differently. I like to break up the IoT product into 4 parts, 5 if you include the security. Most important at the center is what I call the software-defined product. This is a virtualization. Now, some of you may have heard of the term digital twin, cyber twin, but this is effectively the virtual representation of the IoT product. Now, when I say IoT product for the rest of this presentation, what I really mean is, IoT is a very overloaded term. So what I really mean is product or system or environment. But all the time, in all situations, the technology is the same. We have a virtualization of the product. That's a software-defined product. Then we have the hardware-defined product. This is what most people talk about. But this consists of the OT network. It's got the sensors. It probably has an embedded system. Then we have the network fabric. I guess you could call this the Internet of Things, where this is what connects everything together. And then very importantly, what I'm going to talk about in this presentation are also the external systems that go along with the IoT product. So let's go through each one of these. First and foremost, what's really important is not to focus on the things. Where to focus is on the value. The software-defined product is where all value is generated. In fact, I call it the trinity of value. The software-defined product consists of an application, it consists of a model, and along with the analytics that uses the common model, this is where all value in an IoT product is generated. All other components, whether it's the hardware-defined product, whether it's the network fabric and the external systems, they're all there just to support this software-defined product. Now, if you're interested, there's an interesting area of science, and it's actually a fundamental area of science called cyber-physical systems. Cyber-physical systems, I kind of got some of the concepts from that as well, the way that they break it up. But this is the science of bringing together, it's mostly for robotics, so for robots, but it's very, very much applicable to IoT, but it is having a virtual representation and having a physical representation. And the big work that's happening right now in cyber-physical systems is trying to bring the two of them together. And this gives us a bit of an idea of what we will be facing as IoT products evolve, but that's the concept of the dimension of time. It's trying to bring time to correlate time in the hardware, in the real world, with the software world. And as anyone who's a programmer knows, the dimension of time is really difficult. It's very difficult to get right. So let's talk about the software-defined product. As I said, it consists of 2 main parts, the cyber model and the application. Now, the concept is similar to a software-defined network. And the idea is when you virtualize it into software, you've got a lot more flexibility in how you use it. Now, also, what's also important to consider is I'm using the example here of a drying machine, but it can be first of all any type of product. Like I said, it can be a product, a system, it can be an environment, but also the application and the analytics and the model itself, they can be distributed across all computing platforms. Now, when I talk about the IoT network fabric, we'll talk about a few more of those platforms. But you have the embedded system, you've got the fog network, which consists of the OT network and the IT network, and then you have the cloud, and you may have a local cloud that they call on-prem as well. So there's really 5 different areas that you can do computations in IoT. There's also an area, actually one of my newest videos, if you want to look at it, is on mist computing. And that's by actually using the controllers, so the microcontrollers on the sensors themselves to do computation. But more importantly here, for the software-defined product is abstracted into two parts. It is abstracted into the model that we're going to talk about, and I'm going to go through an example of what the modeling is, and the app. So everyone talks about the app, and again, the app can be abstracted. Now, what's really important here, what really brings a lot of the power of an IoT product versus a connected product versus a smart product, is that by virtualizing it, we can interface this product with the internet. By virtualizing this product and interfacing with the internet, we can extract a lot more value than we could otherwise when it was by itself. Now, modeling is something that's probably not new to a lot of people in the audience. You know, we've had models for many years. In fact, I started my career doing computer graphics. We were doing computer graphics. I wrote tools that people that animated dinosaurs for the first Jurassic Park movie, for example, were using. We used models. We had a number of different types of models. The models that I worked on were the geometric models that describe the outside surface of the dinosaurs, for example, or they were cars, or whatever the case may be. We also have functional models. So some of my clients, when I go and I see them, they go, well, we've had models for a long time. You know, it's a cause and effect model. One of them is a connected aircraft project that I'm working on, where they model effectively the aircraft control system. So modeling is not new, but what's new here is that we're applying the modeling to the value that we're trying to create with the IoT product. Now, there's two different types of modeling, and not to get too deep about it, but there's parametric modeling and non-parametric modeling. Parametric modeling is using our physics, it's using our mathematics to represent something. But when you start getting in the real world, it gets really hairy really quickly, meaning that it's really difficult to simulate the real world with these, I guess, mathematical formulas that we learned in university or even before that. So really in IoT, and we're going to talk about analytics in a few minutes, we're using statistical models, and these are called non-parametric models. The application is what you would expect. So this is where the product intelligence is. It also controls the network. It orchestrates the data. And remember, what we're trying to do is do something interesting with the data. So I'm going to say this the first time, and I'll probably repeat it a number of different times throughout this talk, but all incremental value from an IoT product comes from transforming its data into useful information. So transforming data into useful information. So this really is an information technology. But more importantly, we have to look at everything that we do from our IoT perspective in terms of value. It starts out with what value we're trying to create. Then what information do we need to gather to create that value? Then what data do we need to create the information to create that value? Then we can get into the hardware, then we can get into the software, then we can get into the actual things, and everything else, like I said, is really just feeding that data to the model and then to the analytics. So this interfaces with the analytics and external systems, and again, it can be distributed across many different computing services. So now I want to deep dive a little bit and go into an example to try to really demonstrate the difference between a connected product, or say a smart product, and a IoT product. So the first thing that you do, this is a process called value modeling. So the first thing that you do is you define your value proposition. So you're qualifying the value of your product with words. So this is a dryer, and the two qualities that we're going to have, so the IoT value proposition for this dryer is dry clothes as quickly as possible or for as cheap as possible, while maintaining their integrity. So you don't want them to wrinkle, you don't want them to shrink. So now the next step is we now need to quantify that. We need to take that value statement and now quantify it into the model. So what does that mean? Well, it means by creating a function. Now, if you're a business person, you're going to go this far. If you're a technical person, you're going to take this function a little bit further, and this is going to be the basis of the value for your IoT product. So, as I was saying in my demonstration, 8 years ago, when I was in Tokyo, was just a fun story. But we were doing this type of connectivity, remote control connectivity, many years ago. And when I fast forward to today, and I look at the value, the incremental value that provides, it's actually relatively low. So in this example, if I could maybe turn on and off my dryer remotely with my phone, I guess that's okay, right? I mean, that's something. Maybe my phone tells me when my load is finished. I suppose, for me that doesn't really get me that excited. But when we start looking at what can we do with IoT, here's two good examples. So the first one is, I want to put my clothes in and press a button and they're going to dry it as fast as possible. And it doesn't just mean that it's just going to run at one speed. Or I want to push the button and it's going to dry it for the least amount of money as possible, meaning that it will take into account the electricity usage. So let's model that. So what we have at a very high level is we have time, which is as quickly as possible, or energy, which is as cheap as possible, as a function of a few things. Now what we're doing with the dryer is we're evaporating liquid, right? So we're going from a liquid to a gas. And if we look at what the components are to go from a liquid to a gas, we have ventilation and we have heat. Now, the reason ventilation is important is that you can see that you don't need heat to dry clothes. You can put your, I don't know if people still do this that often, they don't do it around here, but you can put your clothes on a dryer, on a closed line outside, even if it's cold, even if it's windy and cold. And then the air brushes off the H2O molecules from the surface of the clothes, and then new H2O molecules go back to the surface of the clothes, and they're blown off again. And this is the concept of ventilation. Now within your dryer, you've got a fan at the back. That fan is blowing air, so it's creating ventilation, plus that drum is going around and around. The second component of evaporation, so going from a liquid to a gas, is heat. So we want to excite the H2O molecules so that they jump off and they leave our clothes, leaving them dry. So now what we need to do is go down a little bit further. So at a very high level, we've quantified it. So it's a function of ventilation, heat, and then electricity pricing, because we want to know what is the cost or what is the price of electricity. If it's electricity-based dryer, it could be a gas-based dryer, so whatever the case is, but whatever that energy is, we want to incorporate the pricing. So now we want to dig down a little bit deeper. What do we need to do to build this product? Well, this is good, we're at a high level, but now we've got to go a little bit more explicit. So, ventilation is a function now of fan speed. As I was saying, there's a fan in the back, but the faster that it rotates, the more air that comes out. It's a function of the angular velocity of the drum, so the faster that it rotates, the more ventilation. Now remember, it doesn't necessarily mean spinning it. There's going to be a point where it's more efficient depending on a lot of different variables, where you don't necessarily just spin it as fast as possible. Now heat, there's the heat temperature. Now what's important here though, because this other part here, maintaining the integrity, you look into the science of drying, if you can maintain the air temperature and the clothes temperature to be equal, then you don't have wrinkling and you don't have any shrinkage or expansion of the clothing. So we need to be able to measure the temperature of the air within the dryer, and we need to measure the temperature of the clothing itself. And again, then we have the energy pricing. Now, what I call these are the pivot variables. This now breaks it down to the point where we now have an understanding of what type of, now this of course is a simple example. When we do real examples, it's the same concept, but they get a lot more complex. But this is an example now. We now know what are the sensors and what are the data sources that are required to be able to have our IoT dryer function. So what it means is we need a sensor that's going to tell us how fast the fan is blowing. We need an angular velocity, we need a rotational sensor telling us how quick the drum is rotating. We need a heat sensor to let us know about the air temperature within the dryer. And this could be done on the heat coil and then doing a function to estimate the temperature of the air. And then we need temperature sensors on the drum itself that will measure the clothing as it touches it. And of course, now this is a very important example, and then we're now going to the internet and looking for external data, so connecting up to a microservice on the internet and finding what the real-time cost of energy is, probably going to our utility company, our local utility company that we pay our bills to. So it's through this process of value modeling that you go from the value statement, from qualifying it to quantifying it. And then this is also the first step when we start doing our product requirements and we're working top down to give to our developers. Again, we start with what's the value. The value is dry the clothing as quick as possible. Then, what's the information we need? Well, we need to understand the ventilation, we need to understand the heat, and what's the pricing. Okay, what data do you need for that information? Well, we need to collect the data from sensors. We need to understand the fan, we need to have the fan speed, the speed sensor, the velocity, angular velocity sensor, the heat sensors, and also on the internet, we need to connect up to a service through an API that allows us to get the energy cost. Now the app, what does the app do? It's going to interrogate the model, it's going to look at the model, and it can actuate the hard-to-find product. Now, since we have this in a mathematical form, we can reorganize it. We can solve for different parts. So in the case of we want to do it as cheap as possible for the least amount of money, then we can solve and minimize this function, put the energy function, make energy pricing, move that out to be equals, and then reorganize the equation so that we minimize the energy pricing variable. We can also do it for time. In this case, it's set up this way initially, but we minimize the variables. Now, I've got to remember, these are different variables now, and they're in a mathematical form. So we can do some analytics, which I'm going to talk about in a minute, but with our app, we can also reverse engineer it. So we can see through, now we'll go to the next step. In the analytics, the first step that we do is that we build models. Now the model, just as a very, is going to be based on, is going to be based at a very high level, going to be based on this concept here. But we start always with the model, and then we need to improve it with the analytics. Now this means relating the variables to an outcome. So let me explain. So we've got situation number one, and we've got, fan speed 1, angular velocity 1, heater temperature 1, drum temperature 1, with the weight of the clothing, which I didn't have in here. So you basically have to weight the clothing wet, and then you can estimate what the amount of water is in it, and then you do your equations from there. So we then associate that with the time, and we see the result. Yes, it was dried in this amount of time. And we do it again for another one. Yes, it was dried in this amount of time. We do it from another model. We do it from other countries. And over time, what we do is we build a statistical model that improves our original model by modifying the constants within that equation. So over time, we're building a more and more accurate model. And then what we can do is we can see, once we have the accuracy of the model developed, then we can go through the process, as I said, is reorganize that model to figure out if we press this button, okay, and it's the dry the clothing as quickly as possible button, it will dry the clothes. We can estimate that exact time and how long it'll take through our analytics. And then what's really important is by using actuators, we can modify the speed of the drum, we can modify how fast the fan is blowing, we can modify also the heat variables as well, the heat that we can control. And by orchestrating all these variables based on our model, we can get that outcome that we wanted, and that is to dry the clothing as quickly as possible. Now with predictive analytics, as I said, we can then look at these models, and then with the input, let's say we put our load in the dryer, and then we can use the predictive analytics to then look at the model and estimate by using signature matching how long it will take for this load to be dried, and it'll have a display. So I'm not sure if this would be a product that I would necessarily buy, but I could make a pretty good argument that this dryer is a little bit more interesting than a dryer that's just connected to a phone that you can turn on and off. Let's go through the rest of the technology now. The hardware-defined product, this just consists of the dedicated system. So you're going to have a dedicated embedded system on there that's going to control the network. Now this network I'm going to talk about in the next section, but what you have in the hardware-defined product are going to be sensors. So in the case of here, the angular velocity sensors, the heater sensors, and actuators, so that you can actually you can actuate the physical world and make changes to it. It also manages the communication on the OT network, and it's going to have the local security. So this is the things part. This is the sensors. This is the embedded system. You're going to be having maybe the app on the embedded system, depending on how you write it. But it's just really a data collection mechanism. So I'm not going to go into too much detail here, but effectively, when we talk about sensors, it's important to understand that really in IoT we're talking about transducers, which are really what the sensors are, converting some form of energy into DC energy, and then we have the connectivity component of it. So, and the other part, so effectively sensors are going from DC energy and converting it with an AD converter to our system, and that puts up the data. I'm going to go through an example quickly. I'm going to be looking at our time, but I'm going to go through an example of how this data moves through the system. And actuators are the other way around, right? You send a digital signal, a data converter then switches it to an analog signal that then actuates in some way or controls the dryer in some way or form. Now, the network fabric, and this is all actually, this is a very short, abbreviated version of a workshop that I put on. It's a 1 and a 2 day workshop. So I generally go into a lot of details. I'm going to talk a little bit about protocols, but I'm just going to go very high level here, just to go through the different components of network fabric. So the first one is that we have the fog layer. Now the fog layer consists of two types of networks. You got the operational network, and you have the IT network. The operational network will always be on the product, or the system, or the environment. So if this was a smartwatch, it would be a really small little network that would be connecting the different sensors within the smartwatch. The dryer is just going to be within the dryer, but of course this could be across the city, this could be across a country, it can be a wide area network, a personal area network, a local area network. But in any case, one of the things that defines the OT network is that the protocols that it uses, I'm going to talk a little bit about protocols, are generally proprietary. So you're going to have an OT network for a car. You're going to have an OT network for a house in the protocol. So you're going to have an OT protocol, I should say, for machinery. And I'm sure a lot of people in the audience have their own OT network protocols that they use for their particular application. So you've got the network. In this case, it's right on the dryer itself. Then you're going to have some sort of radio control. Most likely, it could be a fixed line, but you're going to go to an IT network. In the case of the dryer, we're going to be using probably Wi-Fi, and we're going to go to our small home network, which in my case is just simply we'll just have the controller, the radio controller for the dryer that connects up to the router, my home router, and then that's going to connect up to my cable, which then goes outside and eventually hits some fiber, and then is uplinked up to the product cloud. Now I want to talk just quickly here, because I know we don't have that much time, but when people talk about protocols, you have to remember that there's 3 different types of protocols in IoT. And they're all nested inside each other, the constructed dolls, the Russian doll, the nested Russian dolls. That's the way I like to think about it. You've got your media protocol, or layer, or standard. They're all synonyms. And that's what type of radio. So in this case, we're using a Wi-Fi radio. It could be a Bluetooth. It could be a 15.411, which is a lossy type network. It could be LoRa. It could be a SIGFA, a wide area, an OPWA, a low power wide area network. It could be a cellular network. So that's one protocol. Then we've got the network transfer protocol. And that's what I was talking about earlier. On the OT network, you're going to be using all the proprietary protocols that are going to get that data from the sensor to the radio over to the IT network. But in the IT world, there's only one protocol, and that's the IP, right? Internet Protocol. Right now we're in version 4. In fact, the product I was demonstrating in Japan, what we were doing is demonstrating how to use IPv6 to actually get into a home network, and if anyone's familiar with that, getting into a local NAT. So network address translated. But more the point is on the IT network, you're going to be using the IP protocol. Now, around the IP protocol, you're going to have an application protocol layer standard, right? All the same thing. The application protocol then puts contextual information around that data so that when it gets to the application, hence the name application protocol, it has some contextual information. We don't want to know where that data was stored. We don't want to have to do some lookup calculation. It's far more efficient to put all the data along with the sensor data so that it can be unpacked. So let's do real quickly here for the dryer. So we're going to have the data that we have. Let's say that it is 30 degrees Celsius, and this is a measurement, a temperature measurement that we're measuring from one of the temperature sensors. So that 30 degrees Celsius is our data payload. Around that, we now put the application layer. And that application layer says, oh, this 30 degrees Celsius, what it is from sensor number 5, it's in degrees Celsius, it's in this model of dryer, it's in this geography, and so on and so on. So what we're doing is we're trying to say, and it's from this location in the dryer. So we're trying to put contextual information around that 30 degrees. Now, around that application protocol, we now have the network protocol. And let's say that it is going to be, a Modbus type protocol, and it's what and so then it can then be transmitted along the line. Then we wrap it around that network protocol. Around that, we wrap around our media protocol. And that effectively allows you to communicate it over the air, so to be able to transmit over the air. In this case, like I said, it'll be Wi-Fi. So it goes over the air, that 30 degrees, which is in the application contextual data, which is in this network, this proprietary network protocol, which is inside the Wi-Fi protocol, then goes over the air, and it connects up to our IT network. Now this is one of the problems with Internet of Things right now, is the difference between the OT protocol and the IT protocol, because we're going to have to do a translation there. So we're going to have to translate into IP. So first of all, we get rid of that network protocol, or I should say the media protocol. We throw away the Wi-Fi protocol. And inside there, we have the network protocol. Then we say, no, that's not going to work because we're on an IT network suite. So we have to get rid of that outside shell, and we switch it up with the shell for IP. Now it has an IP shell and protocol, and it goes on our IT network, goes through uphall with a fiber link from my house up to the product cloud. And in there, now we start getting to our servers. All right, so it reaches our servers, it then strips off that network protocol, and in there we have our contextual data that tells us where that 30 degrees was from and how to use it. And that goes into the application. Now, sometimes how you do this, and again, this comes from this whole concept of connectivity. Sometimes it'll just be a cloud. And so the cloud, you buy a service, the cloud may have some agent that sits on the OT network, or probably not. Most of the times it'll just be, you just connect up to the cloud, and you might have a specific product cloud. Now you can build this all yourself, but I always recommend this is unless your business or your core competency is in networking, to me it does not make a lot of sense to build that yourself. So you've got IoT platforms. And this is similar to what I was selling in 2008 for home automation, so it's like IoT. But the IoT platform, that's going to include your cloud. That's going to include pretty much all the plumbing, and hopefully it's going to allow you to have some software that's going to sit on here so that you can translate the data all the way through, as I was talking about, through the protocols into the application. Now there's 3 different types of IoT platforms. You have your AEPs, which is your application enablement platform. You have your connectivity platforms, and then you have the provisioning platforms. And again, the application was most important, where we don't have much time today, but in looking at your IoT platform, you really want to look at, because where's the value? The value is in the model, in the application. So you want to look at the application development environment, you want to look at the modeling environment, and, well, pretty much it's going to hook up to any analytics package. So now let's move on to the external systems. And this is what makes, I think, one of the most important parts of what makes an IoT product an IoT product is now you can connect up to the external world. So we're not just limited to the sensors that we can that we can collect on our product, we can now connect with analytics. So that's an external system, which I was talking about, and I don't talk about it here, but so we have analytics. So in the case of the analytics, there's, just to go very high level, we've got 3 different forms of analytics that we want to look at. And it's really been illustrated to think about it as the past, the present, and the future. So you might have heard these terms, but in the past, you do an analysis, you do analysis, and you try to understand what happened back then. So what happened before? And you may also use something called descriptive analytics, where you color the data in a way that the human brain can maybe identify abnormalities or outliers and just try to get an understanding of what's happening with the data. Now, analytics, again, is one of the 3 areas of what I call the trinity of value, which is transforming that data into useful information. So if we look at what happened in the past, that's the type of analysis or descriptive analytics. Then in the present, we've got real-time streaming analytics and rules engines. And that's saying, what's happening now? What's going on right now? And then looking into the future, we kind of look to the past, and that was the example of the dryer, where we build a model, and then we can see when the variables in that model that I talked about with the dryer, when these variables are in this configuration, then what we've seen before is that, well, it's probably going to break. Something's going to break, or in the case of this example, so that was if you do predictive maintenance, but in the case of this example, well, we believe when we've seen the variables, so the weight of the clothes, and and when we set up the speed of the dryer, the heat of the dryer, and these configurations, we can estimate by looking at the past. We can estimate in the future that the clothing will be dried in this amount of time. So you've got predictive analytics for the past, and you also have prescriptive analytics, which then goes a little bit further and says, okay, I can see what's going to happen in the past. Now, what I can do is maybe articulate with our actuators. I can change our physical product to make it try to achieve something in the future. So we're going this a little bit further. So we can spend easily multiple hours, and I do actually in my course on analytics, but let's move now to external data. So external data, this is beautiful. So this is things like weather. This is things like cost. This is things like inventory. This is connecting up to, again, information services that are used in the web for software programming that we can now apply to our hardware. And again, this is really important. A very important point is by virtualizing our physical product into something that's virtual, we can now take advantage of all the tools that we've been using in web programming, all the libraries, all the frameworks that are existing to be able to accelerate our development and to be able to do far more sophisticated type calculations. So external data in the case of our dryer, remember this was hooking up to our utility company and just seeing what's the cost of our energy, whether that's electricity or whether that's gas. Another external system is a business system. So this is connecting up. In this case, it probably doesn't make sense, but it would make sense for the manufacturer of the dryer, is that I'm a customer, and I want to know how often this customer uses the dryer, what way do they use the dryer. So those are 2 models, by the way, utility models and usability models. And by the manufacturer of this product, they then can hook up that data and put it into their CRM system. You can use other information from this model and put it into your PLM system. They're all ERP systems, so these are all your business systems. You can make connectivity with them. So being able to move that data from the physical into your business systems is very powerful instead of doing the sneakerhead or when you're typing in yourself. Now another important point here is with an IoT product, you have this window, this 24-hour, 7-day-a-week window into how your customer is using your product. You can use that to develop it better, and to also maintain it better, and to maintain a better relationship, like I'm saying, with the business systems. Now, lastly, and probably most importantly, lastly and most importantly, we can connect up, once we virtualize the product, we can connect up our product to other products. And another IoT product, once it's virtualized, is really just another system. So it's another external system. And this takes me to the last and most important slide. evolution of IoT technology has been happening is on this path, and I'm going to sort of try to extrapolate where it's going and why I'm trying to make the case to you to think about an IoT product, an internet product, versus just a connected product or just a smart product. So we started, and it's not even on the graph, it's out here. We started with dumb products. And that's actually my dryer. The dryer that I have in my house is a dumb dryer. Then we moved to smart products. Okay, so we've got maybe some embedded intelligence, there's an embedded system, maybe we do some local computing. Moving along with connected products. Yeah, this is the example I was doing in 2008. I was connecting up to my lights in my office. I was connecting it up to the dryer. In fact, we used to call it the spooky room. So at any time during the day or night, things would be changing in this room remotely. That was 2008. That was 8 years ago. Now what I'm finding is that today, and you're seeing it in consumer IoT today, I don't know how many people in the audience are on consumer, but it's really difficult to justify an increase in price just for providing connectivity. Maybe a little bit of remote monitoring, maybe even remotely turning it on and off. It's difficult. People almost expect that type of connectivity in a contemporary product. That's a connected product. That's something, again, it's so 2008. So then we moved to the IoT product, and I kind of explained it very quickly today, where it's not only a product where you connect it up to external systems, you virtualize it, and by virtualizing it, you can bring to bear all the power of the internet onto the problem. In this example, we're using external data sources, we're using really high horsepower to figure out our models initially with the analytics, and then we're doing the calculations of the model in real time to change the configuration for the variables of the dryer to achieve a particular goal. In that case, the two goals were make it really cheap, so I'm not spending very much money, or do it really fast. So this is what we talked about up to now. Now, the concept of having an external system being another product is we can now start putting together networks of IoT products. So generally, this example isn't necessarily a good one, but this starts bringing up the concept of outcomes. What does the customer want? What is the final outcome that they're looking for? So with IoT, technically, what we can do if we then virtualize our products and make them into internet products is we can connect multiple products together, and we can orchestrate those multiple products together to achieve a particular outcome. So in the case here, this is maybe a weak example, but maybe we can bring together the washer and the dryer. I guess that's pretty much all we can probably do, but that would be our product line, right? So this would be a network of IoT products. Now, when we extend this a little bit further, so now what we're using here to do connectivity, as I recommended, would be using an IoT platform. The same case now is when we move to now having networks of IoT products. Technically, it's a network of products. What that means is it's multiple product lines, potentially from the same vendor or from multiple vendors, that are all working together, again, to solve a particular customer problem. Now, I'm going to use an example from one of my clients, and this is a fun example. My client is a third-generation mousetrap company. So the grandfather of my particular brother, the two brothers that I'm working with, their grandfather was a Hungarian chemist. He was developing wallpaper paste, and he kept finding that mice would stick to it. So he pivoted his business, and he started doing sticky mouse traps. His son, which is their father, grew the business by going into the commercial world and expanding it greatly. And his two sons, who came and took my workshop over a year ago, they read about IoT, and they wanted to apply IoT to the mousetrap. Now, the reason I bring up this example, and this is very important now as I shift into business, is that once you start connecting, once you're starting to focus on value, and that is trying to get closer and closer to the customer outcome that they're looking for, certain things happen from an industry point of view, from a competitive point of view, that may change the way that you strategize or the strategy of your business. And in this case, which is really funny, because if we think about, or illustrative, if we think about a mousetrap, people don't want to own the mousetrap. And they certainly don't want to own the mice that are stuck inside the trap. When we talk to our customers, so we developed our IoT prototype, and this is for another conversation, how we roll this out. When we talk to our potential customers, we understood that what the outcome that they wanted was a clean and safe environment, so they could pass these inspections. Now in this case, this was commercial bakeries who we were talking about, because it's one of the biggest customer groups for our customer based out of New York, for my customer based out of New York. Now, the outcome that they wanted was a clean and safe environment to pass inspections. Well, it turns out that there's actually 3 different industries, here they are, well, this represents them, that actually does that. The first one is actually sanitation. We want to keep the environment clean. If we keep the environment clean, then the mice don't want to come inside. The second one is construction. If we maintain our integrity of the perimeter of our environment, so it's just like a fence, it's just like a wall. We build a wall, we don't let people in, we don't let the mice in, then that's a good thing. And lastly, and only lastly, is once the environment is clean and somehow that mouse still smelled something that was attracted to him, and he somehow was able to make it into the building from the outside into the inside, then, well, that's when mouse traps come in and we want to start catching them. So it's almost like security. So just very quickly, what we're looking at here is 3 different product lines. Product lines from sanitation, so cleaning systems. Product lines from construction, so again, maintaining integrity, and product lines for our catching our mice or our mouse traps. So what's really important is when we start thinking about our strategy, we look at what the technology can do, and we understand that to be able to achieve that outcome, that desire that our customer wanted, we need to bring together more than just our product. Products are a means to an end. And that takes us a little bit to the business models. So in parallel, on the technical side, we have the IoT platform. That's what we've been talking about. IoT platform can bring together the different components of the IoT product, can bring multiple products together, and it can bring multiple product lines together. The counterpart is the ecosystem. Don't get it mixed up. People will talk about the ecosystem, but the ecosystem is really a business, is the business. It's the monetization, is how we make money with the technology. So it's monetize is bringing together the producers and the consumers of the IoT technology and making money from it. So when you start thinking about your business, you start thinking about, well, if we're actually going for the outcome that the customer wants, this may mean we may have different competitors, or we may have certain partners that we want to work with. So that's a topic for another day, but more what I want to leave everybody with here is what we need to do when we look at IoT is we need to look at it from a value perspective. We need to go top down. We need to think, what's the value proposition? Then we quantify that value proposition. We say, what's the information that we need? By quantifying it mathematically, eventually, we're going to understand what's the data that we need to collect that information that we need to generate that value that we want. And then below that, there's going to be and I'm going to send this report to everybody that I have their email address. But then there's going to be a certain order in how you want to build out your technology, because there's dependencies. Again, there's dependencies between different technologies. For example, a database and an analytics system, but really the dependency on the database, what database you choose, depends on what analytics system you choose, which depends on the information you need, right? So the information you need. So there's a whole level of dependency. So what I want to leave everybody with is that don't think connectivity, don't think smart, think internet product. That's how you're going to be able to generate value. Then think about the technology, how it's going to evolve. That's going to directly then apply and map to your industry. And that's going to help you on how to position your company, what type of partners you should be getting for your company, and most importantly, what type of features, and this goes through the requirements process, what type of features you want to be able to achieve this end goal. Now, even though this may still be 5, even 10 years away, you want to start thinking about this type of evolution for your business, because in any particular time, wherever we're on this time dimension, there are going to be multiple right answers. And so if you have a strategy in place, understanding how the technology is going to move, how the business is going to move, is going to help you make better decisions here. And it's also going to help you decide, do I want to be an ecosystem player? Who do I want to play with, or do I want to develop an ecosystem? Because every single vertical will be developing their own ecosystem. Okay, well, I think that's it before we get to questions. So again, my message is develop an internet product, not a smart connected product. Now, I will be given I'll be sending you an email if you're interested. I'll be sending you an email with the report that will include this information. And of course, you're able to subscribe at any time, but I do send out a newsletter every 2 weeks. And feel free to contact me here. Podcast was already mentioned, and I'm open for questions. I'll put my face back on the screen for questions.
Thank you a lot, Bruce, for these great presentations. Definitely, we got some new ideas on how to define products for IoT. And actually, a follow-up question from one of the startups from Dublin is actually, maybe percentage-wise or in some other measure, you could say, where do you see longer-term value proposition in IoT? Would it be providing smart devices? Would it be providing the network connectivity? Or providing services based on data? Or even something else?
So network connectivity is plumbing. Network connectivity is a means to an end. It's not that it's not difficult to do. In fact, it's a difficult problem to solve. But it's not it's something that will be commoditized. In terms of where the real value is, it's going to be in the third one. It's going to be providing services. And we didn't talk about business models, but if we look at the different business models that the technology enables, it'll allow you to do business models such as service business model, but eventually an outcome business model. But where the real value is going to be is in developing the services that are taking this data and putting it into useful information that the end customer can use.
Okay, today I have a launch of LoRa network in Lithuania, so that's the first, let's say, low power wide area network in Lithuania. So maybe you could elaborate what new business cases does low power wide area networks create, and what, let's say, exotic use cases could you tell us?
So again, what's important in a low power wide area network isn't the network itself. What's really important in the case of LoRa is the business model. So, we were talking earlier about the different types of radios. So in some cases, if it's really close, you're going to use a Bluetooth. That's going to make the most sense. You have to look at just the physics of it, right? The frequency, so basically what type of fidelity you need, what type of energy you need, and what type of distance you need to communicate it over. So until now, we had kind of the close stuff down. So if you're a wearable in the wearable market, most likely you're going to be connecting your object through Bluetooth to your phone. Your phone's then going to be connected either through Wi-Fi or through a 2G, 3G, 4G connection to the internet. Wi-Fi is pretty much known. Like for example, in the dryer example, we would use Wi-Fi. There's a network class called that Thread uses. It's called 15.4.11. That 11.4 that allows you to communicate over lossy networks. But LoRa or LP or low power wide area networks, the characteristics are the data is really the low frequency data, but it goes really far and it doesn't take very much battery. So what's important there isn't so much the characteristics, although you have to fit it in, but what's important is until now, the only way that you can connect up to an object, let's say in the middle of the farmer's field or in a mine, these are good examples, or on a mountaintop, would be through a cellular connection. The cellular connection is very expensive. The business model of the cellular connection, you're going to probably be looking at, there's two different forms, but initially, just from a hardware point of view, to get the radio working, you're going to be looking at least a $10,000 to, let's say, $30 cost per subscriber, and then there's going to be a cost. The LoRa rate is in the unregulated spectrums, and it uses a different technology. Then the cost of it's much lower. So the use cases, you know, I can tell you that they're going to be ones that are going to be, they don't require much data, they are going to be far away, and they're not going to require much battery changing. But most importantly, it's going to open up different business models that are going to make products that are possible, because the cost of doing it now is going to make a lot of sense. So like maybe traffic lights, parking meters, something like that. But I don't know the details, but I think more important the point is the business model.
Okay, thank you. And the last question would be, in the foreseeable future, 1 year, 2 years, 3 years from now, which areas of IoT do you see developing the most? Would it be like autonomous cars, smart cities, wearables, or anything else? What's your opinion?
So the way I like to break up IoT is kind of into 4 different classes. So we have our consumer IoT, and this is things like autonomous vehicles, smart homes, smart appliances. We have our commercial IoT, so this would be things like telematics, this would be things like insurance. And we have our industrial IoT, you hear a lot about that. This is when you make something. So you're manufacturing, you're growing something, you may be mining. And then you have infrastructure IoT, which is often what LoRa will be used for, where you're communicating over a large environment. It's really difficult today if you're in the consumer space, autonomous vehicles notwithstanding, because they're still a little bit in the future. But there's a lot of costs that's associated with building an IoT product. But right now, if you look at, for example, a thermostat that's in the home, or a lock that's in the home, to buy them, it's around 10 times the cost. Why? Because you have all this back end. And right now, the consumers are used to the business model where you pay for one time and then you use it. But it's really difficult to justify a 10x cost if it's just a connected product. We get a little bit further, for example, with the Nest thermostat. So looking forward in terms of time, I think it's really going to be extrapolation. We're just looking about 3, 4, or 5 years in time. I think it's going to be extrapolation of where we are today. Where we're making money today is in the 2 middle segments, in the commercial IoT and in the industrial IoT. Because if you think about that evolution, and you think about the value part of it, there's 2 different areas that you're adding. You're either making things more efficient or you're adding new revenue. We didn't talk about that today, but where we're seeing, or where I'm seeing with my clients, the most traction is in manufacturing. So specifically in Europe, in particular on the shop floor with Industry 4.0, that's where we're seeing a lot of money being spent, a lot of money being done, and we're seeing it in terms of fintech, and in terms of telematics, or as I was saying, like fleet management. And I think that's going to continue for the short term. The hard part on the infrastructure IoT, so on that other end of the spectrum, is that you're dealing with cities, you're dealing with countries in some cases, and it just takes a lot of time, to be able to actually work. And one of my podcasts actually was with the CIO of San Francisco. If you're interested in, in LoRa type technology, if you're interested in deploying in this type of environment, and you talk to them, it's going to take a while. It's going to take a while before not only do they have the network infrastructure in place, but they open it up to developers. On the consumer side, it's going to take a while because the value proposition has to be worked out. Right now, it's not there. And I was talking about value using the dryer as an example. So really, I think in the short term, or in the shorter term, where the bulk of the money, it's kind of going to be like a bell curve. It's going to be in that middle on the commercial and the industrial side.
Okay, Bruce, thank you a lot. We very much value your insights, and we hope that IoT will come sooner, and we'll try to do something about that here in Lithuania. And I really hope that you will hear some good examples coming from Lithuania and hopefully reaching Silicon Valley as well. So thank you for this early morning talk to us, and greetings from the crowd here.
Thank you very much for taking the time to listen, and thank you to Startup Scale Up and